You made a noise. Right now. Reading this. Your brain just fired. Your lips might have moved. And somehow, that is the most insane thing in the universe. Because here's the thing, you just use language. And you have no idea how you did it. Nobody does. Not really. But we're about to crack open the machinery behind this everyday magic. And trust me, you'll want to stay for what's coming. It's a wild ride from the absolute bottom to the limits of human thought. If you want to keep exploring the weirdest corners of our minds, hit subscribe so you never miss a video like this. Start, your brain took an abstract thought, converted it into a sequence of tiny muscle movements in your mouth, pushed air through your throat in precise millisecond-timed bursts, and turned it into vibrating waves of pressure that hit someone else's eardrum, and somehow reconstructed your original thought inside a completely different brain. Wah. Like, what? That's not communication. That's actual telepathy with extra steps. And we do this casually. While driving. While eating. While half asleep texting lolk. And somehow that means something. So here's today's question. The only question that matters right now. How does a random sequence of mouth sounds mean anything at all? And because it didn't always. Go back far enough, and your ancestors were just screaming at each other in trees. They had no words, no grammar, no way to say, hey, there's a tiger behind you, run. Just vibes and gestures and fear. And somehow, from that absolute chaos, humans built something so powerful that you can read a sentence written by someone who died 1,000 years ago and feel exactly what they felt. That is absurd. That is beautiful. That is linguistics. Welcome to the bottom. We're going all the way up. Let's start with the smallest thing. The actual atom of language. The building block so tiny that it doesn't even mean anything on its own. It's called a phoneme. And a phoneme is just a sound. That's it. Not a word. Not a syllable. Just a single distinct sound that your vocal system can produce. The P in pit. The B in bit. Those are two different phonemes. And here's why that matters. Swap one phoneme and you get a completely different word. Swap the P for a B and you go from pit to bit. Swap it for an H and you get hit. Same everything else. One sound. Totally different meaning. English has about 44 phonemes. That's it. 44 distinct sounds. And from those 44 sounds, you can build every single word in the English language. Every novel. Every rap lyric. Every passive-aggressive email. 44 sounds. That's the whole alphabet of human speech. Now here's where it gets interesting. Other languages have completely different phonemes. Some languages use clicks, literal clicking sounds made with your tongue, as phonemes. Wah! The Ta language of Southern Africa has about 130 phonemes, including multiple types of clicks. 130. English speakers can't even hear the difference between some of them. Your brain literally filters out sounds that don't exist in your language. You stop perceiving them as distinct. Language isn't just changing what you say. It's changing what you can even hear. But we're still at the bottom. Phonemes don't mean anything. They're just sounds. To get meaning, you need the next level up. Morphemes. A morpheme is the smallest unit of language that actually carries meaning. Not the smallest sound. The smallest chunk of meaning. And here's the move that makes this click. The word unhappiness contains 3 morphemes. Un, happy, and ness. Each one contributes something. Happy is the core idea. Un flips it to its opposite. S turns it from an adjective into a concept you can talk about. 3 morphemes. 1 word. Layers of meaning stacked on top of each other, like a linguistic sandwich. And here's the cool part. You already knew all this. You've been doing this your whole life, without knowing it was called anything. When you see a word you've never seen before, like unbreakability, you don't panic. You just crack it open. Un means not. Break means break. Ability means can be done. Not. Break. Can be done. Unbreakable. You just decoded a new word in real time using your internal morpheme database. You've been a linguist this whole time. You just didn't have the vocabulary for it. Okay, now we've got sounds that build meaning. But meaning alone isn't language. You can grunt food and communicate something. That's not language. That's a dog. Language requires order, structure, rules. And this is where we need to talk about something that's going to make you feel both validated and personally attacked. Syntax. Syntax is the system of rules that governs how words get arranged into sentences. It's the reason the dog bit the man and the man bit the dog use exactly the same words but mean completely different things. The order matters. English, the default structure is subject, then verb, then object. The dog, subject, bit verb, the man object. You absorbed this rule before you could read. You've been following it every day. And you probably never once thought about it. But wait, not every language works this way. Japanese puts the verb at the end. The dog the man bit. Latin doesn't really care about order at all because it uses suffixes to show who's doing what. The word itself tells you whether something is the subject or the object, not its position in the sentence. Some languages are verb first. Some are object first. Across the roughly 7,000 languages alive on Earth today, linguists have found almost every possible combination. And somehow, they all work. Somehow, every single human culture independently figured out a way to combine sounds into meaningful sentences. Every. Single. One. That's not a coincidence. And that's our first clue that something much deeper is going on. So why does every human culture have language? Why does every child in every corner of the world pick up language the same way, in roughly the same order, at roughly the same speed, without anyone teaching them grammar lessons? And a 2-year-old doesn't get grammar textbooks. They get vibes. They get exposure. And yet, within a couple of years, they're producing sentences they've never heard before, applying grammatical rules they've never been explicitly told, and making specific predictable mistakes that linguists can forecast in advance. Across cultures. Across languages. Across history. That's not learning. That's activation. And this is where Noam Chomsky walked into linguistics in the 1950s and absolutely broke the field. His argument was this: children can't be learning language purely from input because the input isn't rich enough. Nobody explains to a toddler that they can't say, "What did you eat?" and a sandwich. You just can't say that. It violates something deep in English grammar, but no one ever told you that. You just know it. Chomsky said, we must be born with a built-in language engine. He called it universal grammar. The idea is that there's a set of deep structural principles, not the specific rules of English or Mandarin or Swahili, but underlying architectural blueprints that all human languages share and that are hardwired into the human brain. Think of it like this. Every phone runs on different software. iOS, Android, different apps, different interfaces. But they all run on certain shared hardware principles. They all need a processor, a screen, a battery. Universal grammar is the hardware. Individual languages are the software. Chomsky called the hardware the language acquisition device. And the moment children are exposed to language, the device activates, latches onto the input, and builds the grammar of whatever language is around them. That's why kids in Tokyo, and kids in Sao Paulo, and kids in Nairobi all follow the same developmental stages. They're running different software on the same hardware. Now here's the part where we have to acknowledge that the internet exists. Because not everyone agreed with Chomsky. Not by a long shot. A linguist named Daniel Everett spent decades living with a small Amazonian tribe called the Pirahã. And he came back with a bombshell. The Pirahã language, he claimed, doesn't have recursion. Okay, what's recursion? Here's the thing. Recursion is the ability to embed structures inside structures infinitely. The cat sat on the mat is a sentence. The cat that chased the mouse sat on the mat is a sentence inside a sentence. The cat that chased the mouse that ate the cheese sat on the mat is a sentence inside a sentence inside a sentence. You can keep going forever. In theory, most linguists thought recursion was universal, the one feature every human language must have. Chomsky actually said recursion might be the defining feature of human language, the thing that separates us from every other animal. But Pirahã speakers, according to Everett, just don't do that. They say, the boy was fishing. Then they say, the boy owned the dog. 2 sentences. No nesting. No, the boy who was fishing owned the dog. No recursion. And if that's true, if one human language genuinely lacks the one feature everyone said was universal, then either universal grammar is wrong, or recursion isn't actually part of it. Either way, the floor drops out from under you. The debate is still not settled. MIT researchers went back to the data and said it's possible, but not proven, that Pirahã lacks recursion. The science is genuinely open. And that kind of disagreement, that live, active, still burning scientific argument, is exactly what makes linguistics wild. Okay? Stop. Pause everything. Because now I need you to feel something. Not just know it. Feel it. About 8,000 years ago, somewhere in a region stretching from Anatolia to the steppes north of the Black Sea, a group of people spoke a language. We don't know their names. We don't know what they looked like. We don't have a single recording, a single text, a single scrap of writing from them. The language they spoke has been completely lost to time. And yet, you are speaking it right now. That language, Proto-Indo-European, is the ancestor of over 400 living languages. English, Spanish, French, German, Russian, Hindi, Persian, Greek, Norwegian, Bengali. They are all descendants of that one lost tongue. The people who spread it were likely the Yamnaya, nomadic herders who exploded out of the Eurasian steppe around 3300 BCE and spread across 2 continents in what was one of the most dramatic population expansions in human prehistory. We know this language existed because of a trick called comparative linguistics. Scholars notice that the word for father in Latin is pater. In Greek, it's pater. In Sanskrit, it's pita. In Old English, it was fader. In modern German, it's vader. Same word. Drifting apart over thousands of years, like tectonic plates. And if you trace the drift backwards, you can reconstruct the original word. You can hear echoes of a language that hasn't been spoken in millennia. That is, without question, one of the most insane things science has ever done. English is weird for exactly this reason. It's a Germanic language at its core, descended from the languages brought to Britain by Anglo-Saxon settlers. But then the Vikings showed up and stirred in Old Norse. Then the Normans invaded in 1066 and dumped a massive load of French and Latin vocabulary on top. So now English has both kingly Germanic and royal French, meaning almost the same thing. It has Ask Germanic and Inquire Latin. It has layers. Archaeological layers of conquest and contact, preserved in vocabulary. This is why English spelling is catastrophically inconsistent. Ta. Through. Though. Thought. 4 different pronunciations for the exact same 4 letters. That's not bad design. That's history. Each spelling preserves the ghost of a different era of the language, frozen in place while pronunciation kept evolving around it. Language is a fossil record. And every weird rule you've ever hated is a dinosaur bone. Alright, so we've got phonemes building morphemes. Morphemes combining through syntax into sentences. Sentences meaning things through semantics. We've got a universal grammar debate that's still genuinely unsettled. And we've got 400 plus languages descending from one ancient language, like a family tree written in sound. Now let's go to the deepest question. The one that sounds like philosophy, but is actually science. Does the language you speak change how you think? And this is the Sapir-Whorf hypothesis, named after linguist Edward Sapir and his student Benjamin Lee Whorf. The idea is that language doesn't just express thought. Language shapes thought. The structure of your language influences, or maybe even determines, how you perceive reality. The strong version of this is called linguistic determinism. It says language locks you in. If your language doesn't have a word for something, you can't think it. Whorf himself argued that the Hopi people of the American Southwest had a fundamentally different concept of time than English speakers, because their language doesn't express time the same way. No past, present, future, in the way English carves it. This version? N. Almost certainly too strong. People who are deaf and haven't learned sign language yet still clearly think. Babies think before they have language. Language probably doesn't completely prison your mind. But the weak version, that language influences how you perceive and process reality, that one has receipts. Here's the experiment. Russian has two separate words for blue. Siny for dark blue. Goluboy for light blue. In Russian, these are not shades of the same color. They are categorically different colors, the way English speakers see blue and green as categorically different. So researchers gave Russian and English speakers a simple visual task. 3 squares on a screen. 2 were the same shade of blue. 1 was slightly different. Which 2 match? Objectively, visually, this should take the same amount of time for anyone with working eyes. But it didn't. Russian speakers were significantly faster, measurably, statistically faster, when the odd square was in a different linguistic category. When they were comparing a Siny to a Goluboy, they nailed it faster. When both were within the same category, their speed advantage disappeared. Wah! Their language made them see faster. Not metaphorically. Faster. In milliseconds. Measured in a lab. This is the thing that should break your brain a little. You don't experience raw reality. You experience a linguistically filtered version of reality. The categories your language gives you actually carve up your perception. Russian speakers aren't just labeling colors differently, they are genuinely perceiving them differently at a level that shows up in reaction time data. And this goes further than colors. Languages that don't use relative directions, left and right, but instead use absolute cardinal directions, north and south, produce speakers who always know which direction they're facing, even blindfolded in a basement. Not because they're somehow better humans, because their language forced their spatial navigation system to stay permanently active. Their whole sense of self is oriented in absolute space. Now here's the plot twist that ties linguistics to every other science. What Sapir-Whorf is really saying is that cognition and language are not separate systems. They're tangled. They shape each other. Which means linguistics isn't just the study of words, it's the study of how the human mind constructs reality. And that connects directly to neuroscience, to cognitive psychology, to anthropology, to evolutionary biology. Think about it this way. A map is not the territory. You've heard that. But language is the map your brain uses to navigate thought. And different languages are different maps of the same territory. Not wrong maps. Different maps, emphasizing different features. Naming different details, giving you different routes to the same place. And here's where the escalator reaches the top, and you can finally see the whole landscape. You started today as a random primate making sounds. By now you understand that those sounds are phonemes, which combine into morphemes, which follow syntactic rules, which generate meaning through semantics, which are shaped by 8,000 years of a single ancestral language, fragmenting and evolving through conquest and migration and contact, which are actively filtering your perception of reality right now, as you hear this sentence. Language is not the thing you use to describe your thoughts. Language is part of the machinery that produces your thoughts. You don't think in pure abstract ideas and then translate them into words. You think in language. The two are fused in ways we are still, genuinely, nowhere near fully understanding. There are 7,000 languages currently spoken on Earth. One goes extinct roughly every 2 weeks. Each one is a completely unique cognitive map. A completely different way of carving up reality. And when a language dies, that map disappears. Not just the words. The entire way of seeing that the language made possible. Gone. And we're losing them. Fast. Which brings us to the question that nobody has answered yet. The one that should keep you up at night. We know language shapes thought. We know different languages carve up reality differently. So here it is. If a language disappeared before we could study it, did it take with it a way of seeing the world that we will never be able to reconstruct? Are there thoughts that have already been lost? Ways of perceiving time, space, color, relationships, entire dimensions of human experience that existed in some languages and have now been silenced forever? We genuinely don't know. Well, what do you think? If our language literally shapes how we perceive reality, does that mean there are entire dimensions of the universe we are completely blind to simply because we don't have the words to describe them? Let me know your theory in the comments below. And if you haven't already, subscribe so you never miss another deep dive into the weirdest corners of our minds.